Hello, grades of. Welcome to our new sessions. And today we're going to be starting with trigonometry. And this is our part one where we'll basically be focusing on the revision. So today we're going to start with a revision where I just remind you some few basics that you learn in grade 11 and in grade 10. Okay. Okay, let's now look at the content outline, and this was taken from Platinum Mathematics Learner's book, and also we'll also be using Mind Action Series Mathematics Textbook and workbook. Okay, so you can see it's Unit 1. We have to do revision for grade 11 trigonometry, and that's what this session will be focusing on. As we move further, we'll do compound and double angle identities and how we can prove identities using this new compound and double angle identities, and also solving equation and determining its general solution. Okay, this is our first part of our revision, and we're just gonna start with definitions and signs of ratios in all the four quadrants, right? So you know that if you have sine theta, you know that it will be opposite over hypotenuse. So it's opposite over hypotenuse, and that is your sine theta. If you have a right angle triangle, you can use those trigonometric ratios in order to solve for unknowns. For example, if you want to calculate the length of that triangle, one of the length of that triangle, you can use these trigonometric ratios. But be very, very careful. We only use these trigonometric ratios like this if we have a what? A right angle triangle. That's where we can say sine theta opposite. What is our opposite? Our opposite is y. That's why they wrote y over what is our hypotenuse? Our hypotenuse, that one that is facing by 90 degrees, which is r. So it will be y over r. Can you see? So in a case where we have adjacent and hypotenuse like that, we say cos theta. We use cos theta, and cos theta, it will just basically be adjacent over what? Over hypotenuse. And you can see your adjacent is x, so it will be x, and your hypotenuse is what? Is r, so it will be x over r. Okay, tan theta is opposite over adjacent, right? It's opposite over adjacent. So what is our opposite? Our opposite is y, hence they wrote y there. And what is our adjacent? Our adjacent is where our 90 degrees is sitting, right? So it is x, so it will be y over x. So those are basically the trigonometric ratios, and how we can define them if we have a right angle triangle, right? So you don't just look at a triangle, maybe they just give you another kind of a triangle, maybe a scalene triangle, something like that, or obtuse triangle, and you start to say if you have theta here, or maybe here you have 30 degrees, and here you have maybe basically it can be 100 degrees, and then there to be 50 degrees, like that. And you start to say maybe this is x and this is 3, and you start to say cos theta x over. No, it's wrong, right? So we only use these trigonometric ratios if we have a what? A right angle triangle. So they are applicable in a right angle triangle and not in any triangle, right? Okay, so if you look now, let us quickly look at this image here, and here they're just basically showing you where those trigonometric ratios are defined. So in the first quadrant, we have all of them. We have sine, we have cos, we have tan, right? It means all of them, they are defined in that quadrant, right? So it means all of them, they are positive in that quadrant. And as we move to quadrant 2, we only have sine, right? And it means that the rest, cos and tan, will be negative in that quadrant, because this is a quadrant for sine. It means if we are using sine, then it will be positive there, right? And the third quadrant, we have tan, and the fourth quadrant, you have what? We have cos. And there's a way to memorize this if maybe you don't understand it, to say all students take coffee, right? They use that notion, all student take coffee, right? Coffee, something like that. So where you say all is in the first quadrant, and S there standing for what? For sine, and that A standing for all, obviously, and T standing for what? For tan, and C standing for cos, to say first quadrant, second quadrant, third quadrant, and what? And fourth quadrant, like that. So this is basically something that you learn in grade 10, and let's not waste much of our time here. Okay, let's now revise reduction formulas. Okay, so these are basically you'll be given trigonometric ratios. Maybe they are long, and you have to reduce them. In order to know how to reduce those long trigonometric expressions, you have to know these reduction formulas, right? So you know that in the first quadrant we have positive theta, like that, right? We have theta, and in the fourth quadrant we have negative theta. So there it's positive theta, right? So there we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and what? And 360 degrees. So as we move back, obviously we are saying from 180 degrees we are decreasing the angle, right? So it will be 180 degrees minus theta, and we know that in this quadrant we have sine, here we have all of them, and here we have tan, and here we have what? We have cos. So in this case, as we move in front, from 180 we must be adding an angle so that it can be able to reach 270. So it's 180 plus theta. Can you see? And as we move from this side, obviously it will be 270 plus theta, but we are not really focused on that for now because those are our co-function. Let us focus on 180 and 360 for now. And it means as we move back, it will be what? It will be 360 minus theta, because we are just subtracting the angle. It's decreasing as you are going back because it's approaching 270. Okay, so let us look at the reduction formula in quadrant 2. For example, if you are given sine 180 minus theta, we know that at 180 minus theta is a quadrant for sine. It means it will be positive, so we can reduce it to say it's equals to what? Sine theta, because that's where our sine is found. So with cos, if we say cos 180 minus theta, on 180 minus theta we only have sine. It means cos will be negative, right? Because it's not defined. I mean, it's not found in that quadrant. So it will be negative what? Negative cos theta in that quadrant. Okay, so if we have tan 180 minus theta, we go to 180 minus theta. It's a second quadrant. It means that we only have sine. It means also tan will be what? Will be negative. So we can see that in the second quadrant, it's only sine that is positive because it's found in that quadrant. Okay, let's go to quadrant 3 now. So if you take a look at quadrant 3, we have tan, right? We have tan. It means that the rest of the things will be what? Will be negative. For example, if we have sine 180 plus theta, 180 plus theta is for tan. It means sine is going to be negative. Cos 180 minus plus theta, 180 plus theta, it's for tan. Cos will be negative, right? And tan 180 plus theta, its quadrant, it will be reduced and it will still be positive. It will be tan theta. Okay, so let's go to quadrant 4. Quadrant 4 we have cos, right? So you must know in this quadrant I have what, right? So in quadrant 4, 360 minus theta is for cos, is the quadrant for cos. It's in the fourth quadrant, right? It means that sine 360 minus theta, it will be negative. So it's the same as sine minus theta, because in 360 minus theta we also have what? Minus theta, and our sine there, it's gonna be negative, right? So cos 360 minus theta, 360 minus theta is the quadrant for cos. It will remain positive even though we can write cos minus theta because we have minus theta in the fourth quadrant, so it will still be positive, right? So with tan 360 minus theta, tan minus theta is the same, right? If I say 360 minus theta is the same as I'm saying minus theta because it's the same quadrant. So tan, we don't have it in the fourth quadrant. Tan will be what? Will be negative. So those are just some key basics that you must know about how you can reduce trigonometric formulas into simplified expressions. Okay, let us also look at special angles just to do a quick revision on them. So we have special angles, right? In trigonometry, we have these special angles, and these are, we have 0 degrees is our special angle, right? So 0 degrees is a special angle, and we also have 30 degree, we also have 45 degrees, we also have 60 degrees and 90 degrees. So this is our 4 special angles. So let me just indicate for you there so that you may not be confused. Here it was 30 degrees, and this was basically 45 degrees, 60 degrees, let me see, and 0 degrees, 90 degrees. So those are our special angles, right? So with special angle, you just need to know this diagram that is drawn here, these 2 triangles, right? Angle triangle, where they have special angles, and you must also know their labeling, so that if they give you something like, if they say sine 30 degrees, right, we know that it's opposite over hypotenuse, so it will be easy for you to just say 1/2 like that. If we have something like sine 60 degrees, you know that it will be opposite, right? Let me show you. Sine 60 degrees, it will be opposite √3 over hypotenuse, which is 2. Can you see? So basically there you just need to know those 2 triangles. Then the more you practice them, the more you'll be able to internalize. If they just give you something like cos 30, you'll be able to say √3/2 without even looking at the diagram, right? But obviously you can use your calculator. It's not really a must that you must memorize them and all that, but just know that these 1, 2, 3, 4, 5 are known as what? As special angles, as you learned in your grade 11 and I think also in grade 10. Okay, let's also quickly revise co-ratios and identities. So if you take a look at your Cartesian plane, where can I draw this? Maybe somewhere here. You have this angle here is 90 degrees and 270 degrees. So those 2 angles form part of the angle that form part of co-ratios, right? So they're part of co-ratios. What do we mean? It means that if you have a trigonometric ratio and you have that angle there, it can change that trigonometry ratio into a different trigonometric ratio. So that's why we call it co-ratios, because it can change one ratio to another ratio to sort of like relate the 2 and to make them equal, co-ratios, right? So for example, what you have to know here is that cos is going to change into sine, and sine obviously is going to change into what? Into cos. And here you must just understand in this where is this angle found? Is it on the first quadrant, second quadrant, third quadrant, fourth quadrant, right? So let me just draw a Cartesian plane here just to enhance your understanding and just to remind you a bit. You know that here it was 0 degrees, right? So if I want to return back there, it will be 90 degrees minus theta, right? I'll be minusing the angle. Going in front, it will be 90 degrees plus theta, right? So we know that in the second quadrant we have sine, and here we have all of them, right? For now, let's not focus on 270. It's mostly unlikely that they can give you, but if they give you, you just know this was 270 minus theta, and this side was 270 plus theta here, because we're going in front, 270 plus theta, and this side to just be 270 minus theta, like that. But for now, let's focus on this one for 90 degrees, right? So if you have cos 90 minus theta, you are going to check 90 minus theta. Where is it found? It's found in the first quadrant, right? So the answer must be positive. It must be positive. So now cos, because they use the co-ratio, they use that angle that can change or that can relate to ratios, then your cos is going to change into what? Into sine. So to be equals to sine theta. So you know, if you have cos 90 minus theta, to be the same as sine theta, right? As you learned in your previous grade. So let us look at cos 90 plus theta. Look at 90 plus theta. Sorry about this. cos 90 plus theta. Look at 90 plus theta. It's found in the second quadrant, and in this quadrant we have sine, right? It means because they use cos is not on the second quadrant. 90 plus theta, cos 90 plus theta is not found in the second quadrant. It means our answer must be what? It must be negative. Then because they use 90 degrees, the cos is going to change into sine. Then the answer will be minus sine theta. Can you see? Look at sine 90 minus theta. 90 minus theta is where all of them are found. It means that the answer must be positive. Then sine, because they use 90 there, it's going to change into what? Into cos. Look at sine 90 plus theta. 90 plus theta. Sine 90 plus theta. It's where we have sine. It means the answer must be positive because it's on the valid quadrant, right? So, but because they use 90 degrees, it's going to change sine into what? Into cos theta. So those are co-ratios, and you can see in the diagram that it can be easily understood if you just sketch that diagram. Okay, so now let us also revise quickly identities. And you learned identities in your grade 10 and 11, right? So you know that tan theta can be the same as what? Can be the same as sine theta over cos theta. So this is an identity. You must, it's like a rule. You must know it, that if I have tan theta, I can change it into sine theta over what? Over cos theta. Or even though I have tan 45, it can be what? It can be sine 45 degrees over what? Over cos 45 degrees. So that is an identity in which you can change your tan, right? So that's it. Or if you have 1 over tan theta, you also have to know, if they say 1 over tan theta, basically they just took tan theta and put it into exponent minus 1. So you can see if I replace my tan theta by sine theta over cos theta, all exponent minus 1, you will see that if I want to make that one to be positive, I'll just basically swap those things to say cos theta over what? Over sine theta. Then my exponent will be positive like that. So if you can see, so you can see that 1 over tan theta here will be basically the same as cos theta over what? Over sine theta. Okay, let's also look at another identity. Very, very important. This one is very important. These two, the one for tan theta and the second one. If you have sine squared theta plus cos squared theta is equals to 1, you must know this identity, right? Because it's a key identity together with the one for tan. Sine squared theta plus cos squared theta will be equals to 1. Even if you have sine squared 30 degrees plus cos squared 30 degrees, use your calculator, you'll get the answer is 1, right? So if you're adding the sum of two trigonometric ratios such as sine and cos being squared, then they will be equals to 1, right? So from that identity we can get two more identities to say, if I want to solve for sine squared theta, I'll just take my cos squared theta to the other side, right? So my sine squared theta will be equals to what? Will be equals to 1 minus cos squared theta. So you must know those identities. And also the last one here is, sorry about this, if you have cos squared theta, then you can solve for it there by taking sine squared theta to the other side, then it will be 1 minus sine squared theta. So this is just a quick reminder for these identities, as they are very, very useful in grade 12, right? Okay, so we just basically been doing the revision and all that, looking at co-ratios, co-function, special angle, all that. Now let's come to this important part of the session, and let's just take a look at this example and see how we can solve it using the knowledge that I've just revised with you in this lesson. Okay, so 1, simplify the following. You are given an expression, an equation. It's an expression, yes, an expression. It says 1.1, you are given 2 sine 90 minus x minus cos 360 minus x divided by 2 cos 90 plus x minus sine 180 plus x, right? So this is simplify. So I want to rewrite that expression. What I will do is we are going to solve each of those trigonometric ratios and simplify them and reduce them like that, right? So let's start with this one, sine 90 minus x. If I can sketch really quickly a Cartesian plane so that you can clearly see this. This is 90 minus x, and this is 90 plus x, and this is 180 minus x, and this is 180 plus x. This is 360 minus x, this is 360 plus x, this is plus x, this is minus x, right? So here we have tan, sine, and all of them, and here we have cos, right? Okay. Okay, so 90 minus x. Let's go and look at 90 minus x, right? It's where we have all of them. It means our answer will still be positive, right? It will still be positive 2. Then, because it's 90 minus x, 90 is a co-ratio. Do you still remember co-ratio? 90 minus x, it will change into what? Into cos, because 90 changes those. If it's sine, it will change into cos. So that will be 2 cos x minus, right? 360 minus x. Let's go and look at 360 minus x. Here we have what? We have cos. So it will still remain positive cos x, right? So this negative here was just for this equation. So negative plus positive, making it to be negative, right? So, but itself inside it was positive. Don't forget that, right? So be careful there when you try to change them. And let's just put it in brackets. 2 cos 90 plus x. Let us look at 90 plus x. 90 plus x is where we have sine. It's in the second quadrant, right? And here they are saying cos. We don't have cos in the second quadrant. We have sine. It means the answer must be what? Must be negative. So because they use 90, it will change from cos into what? Into sine, right? Minus sine 180 plus x. 180 plus x, we have tan, right? We have tan. It means that sine is going to be what? Is going to be negative, because we have tan. 180 plus x is the third quadrant, and we have tan. It means that sine there, it must be negative if we reduce it, minus sine x. And just put it in brackets so that you may not make a mistake there for signs. So that one will be 2 cos x minus cos x divided by 2 sine x. Negative and negative, it will give me positive. This is minus sine x, negative positive sine x, right? So 2 cos x minus cos x, I'll be left with what? With 1 cos x. Then minus 2 plus 1, I'll be left with what? With minus sine x. Okay, so cos x over sine x is what? Remember the trigonometric identities. So we can change it into negative 1 over tan x. Do you still remember? So if we have cos x over sine x is the same as 1 over tan x, right? So don't forget this Trig ratio. So because it was negative, we'll still keep the negative, and that will be the final answer there. Okay, so that's basically how we can simplify, and you must just be knowing in this quadrant I have what, then you'll be able to change that, and it's very simple like that. Okay, let us look at 1.2. Okay, 1.2, you are given tan 180 minus x, tan 45, cos minus x, right? Cos minus x, divide by sine 180 minus x. Let's start. Tan 180 minus x, we go and check. 180 minus x is in which quadrant? Second quadrant. We don't have tan, we have sine. It means that if we reduce that, it will be negative tan x, right? Because 180 minus x, we have sine and we don't have tan. So tan will be negative. Multiply by tan 45 is a special angle, right? You can go and use the triangle for special angle to get tan 45, or you can just punch your calculator simply, then it will give you the answer 1 over 1, which is basically 1, right? So tan 45 is 1 over 1, which is 1, because 45 is a special angle. cos minus x. We know that on minus x we have cos, right? It means that is a quadrant for cos. It will still remain positive, right? Positive cos x, because minus x is found on the fourth quadrant, and that's where we have our cos there, and it's gonna be positive to still remain positive. Sine 180 minus x. 180 minus x is on the second quadrant, and we have sine. If we reduce it, it will still remain positive, so it will be still sine x, right? So what can we do now? We have minus tan x times 1. It will just be that times cos x over sine x, right? In order to simplify this, we can change tan x, right? Tan x can be changed into what? Sine x over cos x. Remember the identity for tan, it's sine x over cos x multiplied by what? By cos x over sine x, right? So cos x and cos x will cancel out each other. We are left with minus sine x over what? Over sine x. This cancel this, and the answer will be what? -1. So basically, to simplify trigonometric expressions, you just need to know this Cartesian plane, and where each of the angles are located, and where each of the trigonometric ratios are identified or defined within that Cartesian plane. Then it will be simply for you. You just apply the rule. So the more and more you practice, the more you'll be able to internalize and just be able to write without even looking at the Cartesian plane. That is, the more you've treated a lot of past papers. But for now, I'd advise you to just draw your Cartesian plane, put the angles, name in this quadrant is found what, then go and simplify your expression. Okay, let's also do this other example. I just want you to internalize this so that when we start with grade 12 trigonometry, that is in our part 2 and part 3 and part 4, like that, you'll be able to just quickly understand the new added knowledge in grade 12, right? Here I'll just show you 2 of them. I'll just show you how to simplify A and B, right? So C and D, I'll just leave it for you. You're gonna do it. It will just be your fun activity for this session. Okay, so A, they say simplify. We have our A. Let me draw our Cartesian plane, right? So here we have 90, I have 180, and I know this is 90 plus theta. This is 180 minus theta. This is 180 plus theta. Here I have sine. Here I have tan. Here I have all of them. Here I have plus theta. I have 360 plus theta. I have 90 degrees minus theta. Let's see. Here I have 0 degrees. Here I have minus theta. 360 minus theta, like that, and here I have cos, right? So that's my trigonometric ratio. Then let us go and simplify. A, cos 180 minus theta. 180 minus theta, we have sine. It means cos will be negative, so it will be minus cos theta, right? Okay. So there's a mark for changing that. Even though you don't know how to solve or simplify it totally, there's a mark for you to just know that cos 180 minus theta can be reduced into minus cos theta. There's a mark there. Cos 90 minus theta. 90 minus theta, we have all of them. It means the answer will still remain positive, right? Because they use 90 co-ratios, don't forget, cos will change into what? Into sine. So it will be sine theta. So don't make that mistake. Don't be too fast when you're doing this, but really relax and just go through it, and you'll be able to solve all of them. Okay, divided by sine 90 plus theta. 90 plus theta, we have sine. It means that the answer should remain positive, right? So because they use 90, sine will change into what? Into cos, and it will be cos theta there, right? Now look at this one. Sine minus theta minus 180 degrees. Now it's kind of challenging a bit, because they are saying minus theta minus 180 degrees. So in order to simplify that one, let me just show you. You just do it like this: sine minus theta minus 180 degrees. You can solve it in 2 ways. I'll show you the longest way first, and also the shortest way, right? So because these are just negative angles, and I'll just show you how you can do this. Then this is the same as sine. If I take the minus outside, I'll be left with theta plus 180 degrees. Can you see? So if I can just write it properly, sine minus into 180 degrees plus what? Plus theta, right? If I make this to be a, then I know I'll be left with sine minus a because there's a negative there, right? And we know that sine minus a is the same as minus angle. It will change. It's in the fourth quadrant, so sine will be negative because it's not there, so it will be minus sine a. So if I still put my a back, it's 180 plus theta. If I put it back there, then minus, now I want to solve this. 180 plus theta is found on the third quadrant, and there is tan. It means sine will be negative there, so it will be negative sine theta. Negative and negative, it will give me positive sine theta. And this is quite a longest method. You see, if I take out negative, I first let that angle and check and all that, going back forth like that until we reach this step. So that one is quite a longest method. Let me show you the shortest one. Okay, with the shortest one, you just need to use the same Cartesian plane, but now you are reversing, right? So now how do you do this? This is minus theta, right? So it means that here it will be what? It will be minus 90 degrees if I'm going back from 0. This was 0 degrees. If I'm returning back, it will be minus 90, but going in front, it will be plus 90, right? So here it will be minus 180 degrees like that. Okay, so now we are fine. So now, if I want to go there in front, I want to reduce that to be minus 90, so I'll be adding. So to be minus 180 plus theta, then there I want to be increasing it obviously to be minus 180 degrees minus theta. Can you see? So now also let me also show you this side. If I want to go there, I want to reduce this one, so to be minus 90 plus theta, but here I want to be increasing it, so it will be minus 90 minus theta, right? So you must also know this Cartesian plane for negative angles, right? So I think this one is the simplest because you just go and check sine minus theta minus 180 degrees, right? Minus theta minus 180 degrees. Can you see? So here's it, minus theta minus 180 degrees. And it's in the second quadrant, and it's where sine is positive, so you can just basically reduce it to sine theta rather than using the long method one. So you can know also this Cartesian plane for what? For negative angles. Okay, so where there is sine minus 180 minus theta minus 180, I'm just gonna put what? Sine theta, right? Then I can simplify that one. Sine theta, cancel out sine theta, cos theta, cancel out cos theta. Then the answer will be what? Minus 1. Okay, let us also do number B. Okay, for number B, we have cos 180 degrees plus theta. So we can change that. 180 plus theta, we have tan. It means there, when we reduce cos, it will be negative because it's not in its position, right? Tan minus theta is on the fourth quadrant, and we have cos, right? It means tan will be negative, so it will be minus tan theta. Divide by sine 360 minus theta. 360 minus theta is on the fourth quadrant, and we have cos. It means sine will be negative, so it will be minus sine theta. Just changing them, you'll be getting marks. Tan 720 plus theta. So for this one, what you do is you are going to reduce this angle up until it is less than or equal to 360 degrees. Let me repeat that. You just basically reduce, using your calculator, you reduce that angle until it is less than or equals to 360 degrees. So we're going to take a calculator and say you do it separately. And how do you reduce it? You reduce it by subtracting 360 degrees, right? Not any other angle. So you say 720 minus 360, then it will give you what? It will give you 360 degrees. So that one we can also write it as tan 360 degrees plus theta. So basically like that. You just reduce that big angle up until it's less than or equals to 360. Then you can change it. Tan 360 plus theta. 360 plus theta, we have all of them. So it will still remain positive because it's on its quadrant, right? So tan and tan will cancel out each other. Negative and negative will go away. We have minus times cos. It will be minus cos theta over sine theta, right? And we know the identity, cos theta over sine theta, like that. It's like the reciprocal for tan. So it will be minus 1 over tan theta, right? So that will be the final answer there. So go and do C and D as your fun activity and just drop your answers on the chats and let me see how many can get this. Okay, let's now look at a different example. So they can give you a trigonometric expression using those co-function and all that, co-ratios, and they say simplify, or they can just basically give you in terms of angles. Like this one, they can give you sine 150, where you just need to first look to say 150 is found on each quadrant. Then you go and check, and you can write it in that way using a reduction formula method. Then you can be able to reduce it, right? So here they are saying simplify without the use of a calculator. So you'll find that when you reduce it, mostly you'll just be getting special angles, and there you can be able to solve without a use of a calculator. So same in this kind of problems, you have to draw a Cartesian plane, right? Let me just make it there. 90 degrees, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, right? So we know that this is 180 minus theta, 180 plus theta, 360 minus theta, and 360 plus theta, and we can also write using those co-functions. I mean, co-ratios, in fact. 1.1, let's go and simplify this one. Sine 150, what do you do if you're given sine 150 or something like this? You check, where can I get my 150? Where is it 150? Is it on the first quadrant, second quadrant, third quadrant, fourth quadrant? Obviously 150 is between 90 and what? And 180, and you must know how is it defined by 180 minus theta. So you can just basically write it as sine 180 degrees minus. So you ask yourself, what angle can I subtract to get 150? So, or you can say 180 minus 150, you'll get 30. So obviously if you say 180 minus 30, it is obviously going to be sine 150. So that's basically how you do. You just check the angle in which quadrant is found, then you go and write it in that formula way in which that quadrant is defined using. So let's go to sine 55, right? Sine 55. Obviously 55 is found between 0 and 90, right? Because it's 55, I might want to choose, I might not want to choose 360 degrees because it's a lot. So I can use co-functions here to say here it can be defined as 90 minus theta. So sine 55 can be written as sine 90 degrees minus. You ask yourself, what angle can I subtract to 90 to get 55? So you say 90 minus 55, and it will give you what? To give you 35 degrees, right? So it will be 35 degrees there. Okay, it's gonna quite take some space here. Times sine 135. 135 is between 90 and 180, right? Between 90 and 180 we have 135, and this is defined as 180 minus theta. So it will be sine 180 degrees minus, so check the angle that you can subtract from 180 to get 135. So just say 180 minus 135 to get the angle, and it will give me 45 degrees, right? Okay, so I think I'll have to delete this Cartesian plane very quickly so that I may be able to do this. Okay, let us move. We go to tan 240. Let's go and check 240. 240 is definitely found between 180 and 270, right? It's on the third quadrant. So it will be defined as 180 plus theta. So we can rewrite that one to be tan 180. We check the angle in which we can add to get 240. So basically you say 240 minus 180, then it will give you 60. So 240 plus 60, 180 plus 60 is gonna give you 240. So that's basically how you do it, right? Okay, let's go under cos 330, right? Cos 330. 330, you ask yourself, where is my 330 located? It's located between 270 and 360, and that quadrant is defined as 180, 360 minus theta. So I'm gonna rewrite it as cos 360 minus, you check the angle you can subtract to get 330. Obviously it's what? It's 30. So 360 minus 30 is gonna give you 330. So cos 145, you check 145 is between 90 and what? And 180. It's between 90 and 180. So they to be defined as 180 minus something. So let's go and get that angle. You can say 180 minus 145 to get that angle to be 35 degrees. Okay, times tan 150. Tan 150. 150 is between 90 and 180. Can you see? Between 90 and 180, and it is defined as 180 minus. So it will be 180 minus something, so that it can be 150. Obviously, it's 180 minus 30, because 180 minus 30 is 150. Let's go to the last one. Cos 225. You check 225 degrees. It's found between what? It's found between 180 and 270. We have 225 between 180 and 270. So it's defined as 180 plus. So it will be 180 plus something, so that it can give you 225. So we'll say 225 minus 180 to be 45. So it is plus 45. So 180 plus 45 is what? Is 225. Once you have rewrite all those trigonometric ratios in terms of those reduction formulas, or even sometimes co-ratios formulas, then you can simplify them and you can be able to solve. So this is a key step, right? If you fail to rewrite them, and it's very simple, you just check. If it's 150, you go and check 150 is found between which quadrant and which, in which quadrant. You check, okay, 150 is between 90 and 180, so it's between that quadrant. So you already have a way to rewrite it. It's 180 minus theta, so it's 180. Just check the angle that you must subtract to give you 150. That's all, right? So once you have done that, it's easy for you to solve this. So let's go. Sin 180 minus 30 degrees. On 180 minus angle, we have sine. So sine will remain positive. If you reduce it, it will still be sine 30 degrees, right? So I'm just going to put it in bracket so to avoid making mistake with signs. Sin 90 minus 35. On 90 minus angle, it's where we have all of them because it's on the first quadrant. It means the answer will remain positive, right? But because we are using 90, our sign is going to change from sine into what? Into cos, and it will be cos 35. Don't forget, be very careful and do this slowly and attentively so that you cannot make mistake, because most people here, they can just go and write sine 35 and you think maybe you got it correct. So also check the angles. So these are co-ratios, 90 and 270. They will change those things, sine to cos and cos to sine, like that. Sine 180 minus 45. On 180 minus angle, we have sine. So the answer will remain positive and it will be sine 45, right? Let's go to the last one. Tan 180 plus 60. On 180 plus is where we have tan. So it will remain positive because it's on its quadrant. It will be tan 60 when you reduce it there. Let's go and divide. Cos 360 minus 30. 360 minus angle, we have cos, right? When you reduce it, it will still be what? It will still be positive cos 30. If you reduce it, cos 30 there, right? Just going to put it in brackets. Cos 180 minus 35. On 180 minus angle, we have sine. It means cos will be negative, right? If we change it to be negative, cos what? Cos 35, right? Then times tan 180 minus 30. 180 minus is on the second quadrant where we have sine, right? It means that tan will be negative. It will be negative tan 30 degrees, right? And also cos 180 plus 45. So with cos 180 plus 45, 180 plus, we have tan there, right? It means our cos will be negative cos 45. Then what we can simply go and do is to change those things, because we now have special angles, right? Sine 30 degrees, you can simply use your calculator. You don't really need to memorize that triangle for special angle. You can simply use a calculator. Sine 30 is the same as 1 over 2. Cos 35, it will still remain cos 35, and because it's not a special angle, 35 is not a special angle, but you can see it has a friend down there. We just basically cancel them out, right? So sine 45, it will be 1 over root 2. On your calculator, it will just give you root 2 over 2, because they've just rationalized the denominator and all that. So it's the same as root 2 over 2 if you use your calculator there. So tan 60 is the same as root 3 over 1. Root 3 over 1. Then we are done on top. Under space here will be a problem. Or let me just write this as small. Okay, there they are. Cos 30 is the same as root 3 over what? Over 2. And there we have minus 1. And there we have minus tan 30. Tan 30 is the same as what? Is the same as 1 over root 3. If I'm not mistaken, 1 over root 3. 1 over root 3. But because it's negative, they will put negative. Cos 45 minus cos 45 is the same as minus 1 over root 2, right? So 1 over root 2 cancel out 1 over root 2 there, and negative will be positive like that. So I can just basically use my calculator to say root 3 over 2 when I multiply this one and that one. Or you can just simply use a calculator once, but they say with that they use a calculator, so let's just follow the procedure there. But to be sure of your answer, you can verify with your calculator, obviously. So here we have minus and minus, so 1 there will be negative, so it will be negative root 3 over 2 root 3. So it will be negative root 3 over 2 root 3. I don't know if you can see that because it's really small. But when you simplify that one, negative and negative, positive, then we'll be left with negative 1 there. Multiplying that one on top to be negative root 3 over 2 root 3. So root 3 and root 3 will cancel out each other there. Then we'll be left with root 3 over 2 divided by minus 1 over 2, right? So if I simplify that, root 3 over 2 multiplied by 2 over minus 1, this one cancel out this one. Then I'll be left with what? With minus root 3. So the final answer will be negative root 3. And you can verify this using your calculator. You can just punch your calculator and enter all these things here. You can just use your calculator and verify. So it's very simple if they give you this kind of problem, because you already know the answer has to be this, right? So you can punch your calculator and verify to see if it will give you minus root 3. Okay, so for 1.2 also, I'll just give you this as your fun activity exercise. Go and try it out and see how you can get it. Okay, let's now look at a different example, and this is one of the key example, because when you start writing your paper 2 in your question 5, this is definitely the question that is most likely that you will get in your paper. They'll just give you an expression and they say express the rest of them in terms of this letter and all that. So if you take a look at the final papers and also trial, June and all that, you realize that this question will always be there, and it's like the first question in question 5. They just give you this trigonometric expression. They say express the rest of them in terms of this. Okay, so let's also revise this, although it was covered in grade 11, but this is a revision, so let's also cover this, right? Just put an example there. They just give you, if tan 22 degrees is equal to t, then write the following in terms of t. So how do you answer this question? So before answering this question, you must first draw your triangle, right? and you must know where your triangle should be drawn. So here we have 22 degrees, and we know that 22 degrees is between 0 and 90 degrees. Definitely our triangle is on the first quadrant between 0 and 90 degrees, because that's where we have 22 degrees. Okay, so if I can just sketch that triangle, this is my 90 degrees, and here I just put 22 degrees. So how is tan defined? You must also know. So if I have tan 22 degrees is equals to t. So we know that if I say t over 1, it's still correct, because t over 1 is the same as t. So my tan is defined by saying opposite over adjacent, right? So my opposite is t, and my adjacent is what? Is 1. So opposite is going to be t, and my adjacent here is going to be what? Is going to be 1. So that's it. Okay, so then you just need to complete that triangle. We need to solve for the hypotenuse, and obviously we're going to use what? Theorem of Pythagoras to say r squared equals to x squared plus y squared, and this is from Pythagoras. You just showed them these workings, right? Because they have marks. So to solve my hypotenuse, I'll just x squared is 1 squared, and my y squared is t squared, and my r will be equals to, if I apply square root, plus or minus, this will be 1 plus t squared, and r will be plus or minus root of 1 plus t squared. Can you see? Root of 1 plus t squared. Because the hypotenuse is always positive, then it will remain what? It will remain positive. So my r there is root of 1 plus t squared. So I can just replace by root of 1 plus t squared, right? Okay, then I can now go and fill out the whole triangle. Don't forget, you have to fill out the whole angles there so that you may not make mistake. So this is 22 degrees, this is 90. Sum of angle of a triangle is 180. So definitely there we have to calculate. So I'll just say 90 minus 22, then I will get what? 68 degrees. Then after filling that triangle, all its angles and all its sides, you can now go and express the rest of the expression in terms of t as the question requires. Okay, we want to express tan 202 degrees in terms of t. Now you get that this angle is not in the triangle, right? It means that we have to what? We have to reduce this expression into a simpler trigonometric ratio, right? We have to reduce it, right? So how are we going to reduce it? You know that we are going to, on the Cartesian plane, and also use the formulas that we just revised about reduction formulas, and also core ratios and all that, in order to reduce this one. So what we basically do, we know that this is 180, this is 270, and this is 360. You check your 202 degrees is found on which quadrant? It's obviously between 180 and 270. And how is that defined? It's defined at 180 plus what? Plus theta, and we have tan in that quadrant. Right here we have sine. So 202 is between 90 and 270. We want to reduce it, right? So that we can express it, because on the triangle we don't have 202. So we have to reduce that angle, right? So obviously we have to use the reduction formulas and all that. So you check 202 is between 180 and 270. How is that quadrant defined? By saying 180 plus theta. So we can rewrite tan 202 to say it's the same as tan 180 degrees plus a certain angle. So you're going to get that angle by saying 202 minus 180. So it will give you 22 degrees, right? 180 plus 22 degrees. Okay, sorry about the background noise there. 180 plus 22 degrees, it's the same as what? As 202 degrees. Okay, so now let's reduce it. We have tan 180 plus 22. It's on the same quadrant there as tan is positive. Then when we reduce it, still remain positive. Tan 22 degrees. Let's express it in terms of t. Tan 22 opposite over adjacent. So it will be t over 1, which is the same as what? As t. So we have expressed tan 202 in terms of t. Can you see? Okay, let's now look at number B. We have tan 338. Tan 338 degrees, right? So let's go and reduce it, because on our triangle we don't have 338 degrees, so we have to reduce that one, right? Let's check. 338 is found on which quadrant? It's between 270 and 360, and that's defined as 360 minus theta, and we have what? We have cos there, right? It's between 270 and 360, so we're gonna rewrite tan 338 as tan 360 minus a certain angle, and to get that angle you just say 360 minus 338, and it will give you 22 degrees, right? So it will be if you say 360 minus 22, you'll get what? You'll get 338. Then we can reduce that tan 360 minus angle. We don't have tan on that quadrant, so if it's tan 360 minus something, it will be negative because it's not on its position, it's not on its quadrant, right? So it will be negative tan what? Tan 22 degrees when we reduce it. Then we can express it, because 22 is on the triangle, you can express it in terms of t. In terms of t, tan 22 was t, so this will be minus t when you express it in terms of t. Okay. Okay, let's now look at C now. You are given tan minus 22. We know that on the first quadrant is positive angle, and on the third quadrant, on the fourth quadrant is negative angle. So negative angle is found on the third quadrant, right? Because it's 0 degrees. If we are moving back, it will be minus angle. We'll be reducing the angle to be negative. Okay, so tan minus 22 is on the fourth quadrant. Then this, and we don't have tan on the fourth quadrant, we have cos. It means tan will be negative. This is minus tan 22 degrees, and this is the same as minus t. Can you see? Simple as that. Okay, let's come to D. Tan 518 degrees. Can you now see 518 degrees, right? It's beyond the Cartesian plane. So what do we do in this case? I already explained this when we were solving, when we were simplifying the expression. So what you do is you subtract 360 from this angle up until you get an angle that is less than or equal to 360. That's all, right? So from 518 degrees, we're going to be keeping on subtracting 360 up until we reduce that angle to an angle that is less or equals to 360. So 518 minus 360 is just going to go to 158 degrees. So it's perfect, right? So we can write tan 518 as what? As tan 158 is the same. So we just subtracted 360, so it's the same. Now we don't have 158 in our triangle there, right? So what do? We have to write it in terms of reduction formula, so that we can be able to express it in terms of the angles in the triangle. Okay, you check 158. Between which quadrant is it found? 158 is found between 90 and 180, and that is defined as 180 minus theta, right? So we're just gonna rewrite tan 158 as tan 180 minus a certain angle that is gonna give us 158. So we say 180 minus 158 to get that angle, and it's giving me 22 degrees. Oh, I think we're getting a lot of 22 degrees here. Let's see. 180 minus 22 is 158. Perfect. But 180 minus, it's where we have sign, right? It means, but because this is tan, it's gonna be what? It's gonna be negative tan 22 degrees. This is negative t. Can you see? Because on the quadrant, tan 22 opposite over adjacent, which is minus t over 1, which is minus t. Okay. Okay, cos 158. We know that 158 is between 90 and 180, right? Cos 158 is between 90 and 180, and that's defined as 180 minus an angle, and we already know it's minus 22 degrees, because 180 minus 22 is the same as what? It's 158. So 180 minus angle cos So on 180 minus angle, we have sine. It means our cos will be negative, and this is cos 22 degrees. We go on our triangle and get cos 22 degrees. Let me use a right pen. Cos 22 degrees, it will be adjacent. So this is minus 1 over hypotenuse. Can you see? Over hypotenuse, which is root 1 plus t squared. So when you express cos 158 in terms of t, it's just going to be equals to minus 1 over root of 1 plus t squared. Okay, the last one, sine 22 degrees. Okay, which this one is simple. Just use your triangle. Sine 22, it will be what? Opposite over hypotenuse. Opposite over hypotenuse. From your triangle, your opposite is t and your hypotenuse is 1 plus t squared. Then you have expressed that in terms of t. So you can basically see that this question that you'll always see on question 5, if you're given, you first really need to draw your what? Your triangle. After drawing your triangle, you can be able to express those in terms of those things. And this need really the knowledge that we just revised in the previous about reduction formulas, how you can reduce this trigonometric expression into simpler trigonometric expression like that, so that you'll be able to solve this question in that you'll always find in your question 5. Okay, here's your fun activity exercise. You're given if tan 38 degrees equals to k, write the following in terms of k. Hint, draw a diagram. So obviously you need to draw a triangle and then go and reduce those formula to their simplest. Then you'll be able to express them in terms of k. Okay, great stuff. Thank you for being with me through this revision. This was simply a revision for your trigonometry grade 11 and 10. Although in this session I didn't cover solving equations and using general formula, I covered it in another session, and its link I'm just gonna post it so that you may also go and revise how to solve trigonometric equations and also using general formula and all that. So our next session, we're gonna be focusing purely on grade 12 trigonometry, this new added knowledge, and that will be our part 2. This was our part 1 where we were focusing mainly on the revision, right? So in our part 2 that is coming this week, we'll be focusing on grade 12 trigonometry. They just added some few rules, a few trigonometric rules and all that, and it's very simple. You'll see it as we do the next session, which will be our part 2. Otherwise, for today, that's it. And thank you very much for watching. Enjoy the rest of your day. Don't forget that practice makes perfect. Practice makes perfect. Otherwise, that's all for me, and goodbye.